6.326 plus 15.0 is that number, right? But what do I need to do to it? Okay, I've got to round it to the least precise measurement, right? What's that?
Yeah, 15.
Oh, whoops. You're right. Plus 15 gives us that. Okay, so I should get then 23.6 what? Oh, grams. Oh, so it's not working. Yeah, that's what you're saying. Jonathan was saying that.
Which number is that?
Number 9.
Number 9.
Oh, I don't need it. You're right, because it's already there. Beautiful. That's the problem. There we go.
It still didn't work on John's. I put everything in. I was like,
Still didn't work?
I got mine to work, but I could not figure out it.
Really?
Maybe it
Yeah.
was just like a little error that you didn't notice, 'cause that's not gonna.
Well, maybe let's check. We'll check it out and see.
Maybe there's.
See what we got. Let's go to those. Oh, by the way, look at here's the calendar. So notice what the calendar looks like. You probably ought to want to check this pretty regularly. So you got the new assignments 2.1 and 2.2 practice assignments. To be on schedule, I kind of was hoping you'd have those done today, but they're not going to go away until the end of Roundup. The 2.3 assignment that I just gave you, it's got 6 problems. I'll give you today to work on it. You can work on it over Roundup also, and I'll give you a day on Monday to ask some questions on that if you need to. The other thing, though, that's kind of important, what I'd like you to do, and you can either do this now or you can do this tonight, but I'd like you to do a little bit of reading for tomorrow. And it's not like this is really super difficult stuff, or even, I don't even really like the way that this book deals with some of this stuff, but I want to have us to have sort of a common background so we can discuss this tomorrow and maybe just take it a little deeper than what the book has to say. So that's just, it's the chapter 3 in the book. It's really short. It's pages 43 through 59, but a lot of that is really not very much reading. I mean, there's some stuff in there, like there's some interludes that I don't care if you read. When I say read that, I mean just read the text. Like for example, on page, what is it? On page, how it works, on page 52. It's kind of interesting. It talks about a speedometer, but read it if you're interested. I don't care about that stuff. I just mean the actual textbook. Okay, so if we go to the 2.3 practice, how can there be 15 attempts on that already? It's crazy. Oh, I see. People have just pulled it up. They haven't started. I got you. Okay, so let's look at a couple of these. I'm going to pick one of the last ones. The first two are just kind of introductory, where it's asking you to look at some, you're going to provide some, like a linear regression model. You're going to just go through that data, write what the regression model is, and then you're going to write what the determination of, or the coefficient of determination, R squared. So how good is it, right? How good is the model? But when you get to these last ones, let's just take one of these. This is something a little different here. What I'm asking you to do is to take this data and determine what the best regression model is, and then use that model to make a prediction about what the velocity is likely to be at 11 seconds. Now, keep in mind here, that might sound like kind of a weird question because that's one of our data points, right? But our data points have some error built into them, right? So when we take all this data, for these times we recorded these speeds, keep in mind that that it's not perfect. I mean, there is gonna be some built-in error, but the more data points we have, the more we can extinguish that error by using a good math model. So there's a couple things. You'll notice as you do this stuff, like in labs, for example, and you'll see this correlation. The more data points you have, the better your R squared tends to be, right? The more that your data is going to tend to adhere to a good model. So even though we collected this data point of 20.9 meters per second at 11 seconds, there's some error in that. And our model is going to give us a better prediction than what our actual data point was. Does that make sense? Okay. So let's look at this. Grab your calculators. If you need one, come up and get one. And let's just go through one of these, and then I'll let you work. Okay, so where are we going to go to put this stuff in? Stat, edit, good. Okay. Okay. So we get all that data in. Then let's say we want to look at a scatter plot of that. How are we going to do that? Yeah, what do? We got to go. Two things we have to do. If I want to produce a scatter plot so I can see a representation of that data, what do I have to do? Say it again. Okay, so I got to go to Y. Now, what do I need to do here? Yours might already be set, but mine's not. Plot 1. Good. I've got to turn on plot 1. And plot 1, I'm just going to go with all the default settings because the default settings are a scatter plot from L1 and L2, right? So now what? I could, but if I click graph, I'm not going to see very much of the data. What was my trick to get the screen to fit the data? Zoom 9, there we go. Zoom 9, zoom stat. And there it is. So what do you think? What do you think that looks like? What do you think? I mean, does it seem, I guess I know what my guess would be. I mean, it looks fairly linear, doesn't it? I would say probably that because this thing seems to be turning up a little bit and then maybe turning down, I'd say probably that's gonna, I'd guess cubic, but who knows? The calculator will tell us, right? So how could we find out which is the best one? Is yours different?
Yeah.
Uh-oh, I probably,
No, we have different information, like different data to begin with.
oh, you do, that's right, whoops. If you're using your computer, yeah, I tell you what, you don't even have to change this, but we'll just use mine, how about? Okay, so this is the data. You don't even have to do this, because you're gonna do the same kind of thing. You can just look at mine. Just tell me what to do though. So what am I gonna do now that I've got my data in there? How am I gonna determine which is the best model? Okay, so stat, calc. Okay, so let's start with the weakest regression and just work our way up, right? Start with the simplest, and we'll just go until we have to, until we find one that's gonna fit. So stat calc 4.
What's I understand the equation's different, but there's a linear regression below that also.
Okay. Yeah, the only difference is the other one is the very same, except the parent equation is I think, was it a plus bx?
Yeah.
So the a is the constant and b is the slope. No difference otherwise. I think this probably is maybe something you're more used to because it fits the form mx plus b. Okay, and then we'll probably want to do just maybe one thing here. What's that?
You gotta change the story.
Okay, yeah, good. Let's go ahead and store this regression equation as y1. So let's go alpha f4 y1. And then we'll calculate. And, oh, whoops. Okay, so this is, you don't have to do this. Because I reset the whole thing, I gotta turn on my stat diagnostics.
What are stat wizards?
The stat wizards are the things that you use. So they're the things that allow you to, I'll show you. Instead of doing, like normally on the old ones, if I wanted to do linear regression, if I hit, I'll tell you what, I'll turn it off. Actually, I'm glad you brought that up, because this is how it will look if you don't have the newest operating system. Let's show you this real quick. Or if you're using like end up using an old one, or if it doesn't have this, you should probably know how to do this. If I turn the stat wizards off, and I go stat, calc, 4, then it doesn't give me that whole screen, right, where I can fill stuff in. I can still do things like I could put, if I do L2, comma L3, what do you think that means? It uses the first one as my X variable and the second one as my Y variable, right? But the default is L1 and L2, so I don't have to do anything like that. But if I put at the end, and I can't remember if I need a comma. I think I do. So if I go comma, and then I go alpha F4 Y1, if I add that argument to that function, I think it's going to then store it as Y1. Oh, maybe not. I can't remember how to do that one. That was kind of, I don't know why, but I'm not going to waste time with it. I tried and failed. I'll turn everything on. So stat wizards on, stat diagnostics on. Let's try that again. Stat calc 4 y1. Okay, calculate. Okay, so we got our equation. Do we need that equation for anything? We don't really need to write those numbers down, right? Because we've stored this as y1, and so we can always just use the math model on our calculator to actually to estimate a value, right? If this ends up being the right regression model. What's probably the important number that we need to maybe look at and at least kind of sort of remember? R squared. So 92.6%. What do you think? Probably not great, but the way we'll really be able to tell is if we go to a quadratic and it jumps way up. If the quadratic's a lot better, then we'll toss the linear regression model, right? So we'll go do it again. So now we go stat, calc, quadratic would be 5, stat calc 5, and let's go ahead and store this one as y2. Okay, and what do we get? So we get new model, R squared 97.8%, quite a bit better. So the linear regression got tossed. Quadratic is significantly better, right? Well, let's try cubic. Okay, so if we go stat, calc, 6, let's store this as y3. And let's see. So R squared didn't really get any better, did it? 97.8%, right? Isn't that what we had before? Pretty sure, right? And then even if we were to try quartic, if the cubic didn't work, well, the quartic's not gonna probably work either. It's probably not gonna be any better. It gets way more complicated.
So
Question?
what is the R squared?
So the R squared tells us the strength of the correlation.
So like how accurate?
How accurate it is, right. So if a quadratic was just about as accurate, maybe this is ever so slightly more accurate, but if the quadratic was almost as good as the cubic, we don't want to go to this much more complicated model. Okay, because for two reasons. Because A, it's a harder function to deal with, and B, it's going to be hyperactive. It's gonna be very frenetic in its movement. It's gonna throw in lots of peaks and valleys, and we don't want those. We want the function to be as smooth and tame as we can. And if we look, for example, now if we go to the graph, you can kind of see this a little bit. There's the linear. Okay, we toss that in favor of the quadratic, but look what the cubic does then. The cubic, yeah, it looks almost identical, right? I mean, you can hardly even tell the difference, so why bother with the harder one, right? If we go one more step and we just try the quartic while we're at it, because it's so easy to do on the calculator. So stat calc 7, store it as y4. And no better really, right? 97.8%. And now if I go to graph, once again, there's the linear, the quadratic, the cubic, and the quartic looks almost the same, but I would say it's actually worse because it's giving us a little more, like at the very left, it starts to curve down more than it probably should. Okay. Now, if I do expand the window, what do you think is going to happen? Right, then things are going to start to diverge, and so that brings up an important question. So let's go to the window, and instead of stopping at X max of 19.8, let's go out to like 25. And then we'll just hit zoom 0 for zoom fit. So the cubic stayed pretty much the same. I bet you this quartic's going to start to deviate a little bit. Yeah, see, it starts to get too curvy. It starts to do all kinds of weird stuff. And if I go out a little bit further, should have gone a little further last time. If I go out to like 30. And then let's go zoom 0 again.
My window keeps going up. Yours goes down. Sweet.
Oh, because you have different data. You have the same data?
No, different.
Different data. There you go. Yeah. And so look, see that quartic starts to do weird stuff at the end, right? Starts to do. What do you think? So we call like, we didn't answer the question though, did we? Whoops, we never answered the question. So if we go back here to our question, we wanted to know what's the predicted velocity at 11 seconds. So what do I do?
Trace.
Okay, good. I can go trace. That's the shortcut, trace. But now, what do I need to do here? Look at that carefully and tell me what needs to happen.
Down arrow.
Good, because right now I'm on the plot. So I'm going to go down arrow. There's Y1. Which one did we want then?
Down arrow.
Okay, we wanted Y2, didn't we? We want the X squared one. We want the quadratic one. That was the winner, right? And once again, that's the winner because there was a significant jump in the quality of the fit from linear to quadratic. But then after that, there were just really, really minor differences, right? So we want the easiest or the simplest regression function that does the job, right? Okay, so then now that we're on Y2, we can just type in 11 and hit enter, and it puts us on the curve and it gives us a prediction of 19.7. We're supposed to go out to 3 places, So what's that going to be out to the thousandth or 3 places? Yeah, 19.740. Everybody see that? Okay. And what is the actual answer that we got here? Well, not the actual answer. Our data was 20.9, so that's a little bit off. Okay, this is a better prediction. All right, so a prediction like this, when the prediction is within our data set, you know what that's called? So if we're predicting inside here, this is called interpolation. I'm going to write that word down. I want to see that. I can't remember if I can write on this thing. Can I write on? I guess I can. So in here, what's it called if we're looking out in this region out here where we're outside of our data set? You know what that is? It's extrapolation. Okay, so which is probably easier to do? Interpolation. Yeah, inherently more accurate, right? Because it's inside our data. Which is probably more valuable? Extrapolation a lot of times. Yeah, a lot of times we want to take something, we want to take a data set and we want to be able to make a prediction that's outside of the scope of our data set for whatever reason. You know, we want to be able to predict, okay, what's going to happen out here, typically later in time, right? Like a lot of times we'll do things like we'll record historical data and we want to make a prediction about the future. So that's going to be extrapolation. That's a little tougher to do. You got to be a little more careful with it. And that's especially why you want to be really careful about using really aggressive regression functions because they just change so dramatically, right? We don't want to get really bad predictions because of that.
So mine was the exact same that I used on the paper.
Yours was, oh, that could be. Could be. I mean, there's always a chance that that data point is going to be right on. Yeah. Yes? It is. Okay, that's a technical term, and we'll deal with that, yeah. Okay, any questions on that? Yeah. No question? Okay, so you can just jump into the assignment. If you got calculator issues, come on up, we'll take a look.
Yeah, I can't get the right answer.
Yeah, I didn't get the right answer.
You didn't get it either?
I got it.
Oh, maybe I should try mine, see if I got the right answer. So what does mine say, 19.74?
Mr. Oya.
Yeah.
I tried all of them at 11 from like linear all the way up to like quartic or something like that, and it said all of them were wrong.
Yeah.
What?
I got mine and I don't know. I just got it.
Did you, oh, I know, okay, I know what it is.
This isn't supposed to be 11.
But
Did you put in the units?
but like she's been having some problems.
Oh, man, this is gonna bum me out if this isn't working.
It's oh, it's meters over second. That's I tried meters and it didn't.
I tried
That's
Well, if you got it right.
Come on, any day here.
use it as for the unit.
Yeah.
Did you get it right?
No.
I can't even get one.
Okay.
Did yours like take a long time to evaluate? So when you, I wonder what's going on with our,
If it's the exact same, do I just enter the same answer?
Number one, like
I mean, it's the same out to 3 decimal places?
Well, I mean, the time in seconds and velocity is 15, like 62.3, y is 60, or 15, y equals.
0.3, like it rounded 62.3 if you rounded it to 3 places?
I don't know, it's just second.
Because it wants it to 3 places. I don't know why this is taking so long.
Oh.
It is? Oh, okay. Uh-oh.
Yeah. Mr. Oya.
That's my fault. Oh, man, I hope these work. These are really nasty ones to build. I don't know.
Mr. Oya.
They were super. What's that?
It's giving us the bottom value.
What's it doing?
It's not giving us the time in seconds, it's giving the velocity in meters per second. So that changed something.
Oh, it's giving you the,
Oh.
Yeah, when it changes the units, the meters.
oh, okay, let me check.
That when it changes the number.
Hang on, I gotta look at the code here real quick and see what's.
How do you do that? Mine's giving me,
Like, are you calculating or?
no, I mean, like mine's asking for velocity and it
gives me a time of 15 seconds.
Yes,
So,
Can you only check out one?
No, you can keep checking.
I'm gonna try.
Oh, hang on. I see what I got going here.
Oh, yeah, I see your problem, it's right there.
Yes, you got it? Hang on. I see what the problem is. Oh, whoa. Hold on here. Copy.
I think it's because he's. Oh, I could check.
Huh.
I think it erased my answers.
Oh, you cooked it.
No, it's fine.
Yeah.
Yeah, mine were.
Man, I just tried to build these. Like over lunch, I was throwing these together frantically, and I might have made a mistake.
How about we just not do it?
Did you build those pretty
We
fast?
talked about it for a long time.
Oh, define fast.
Like within hours or?
Yeah, within hours. Yeah.
That would take me years, so I was.
Did you try to
fast?
Type all of that?
I would think
Yeah.
hours are relative. Fast relative to years.
Let's see. What now?
I think that's about
Okay. I tell you what. Don't start this. I'm gonna delete all the attempts because I have to fix something. It'll take me like I'll fix it this period, I think, and then you can restart it.
But I've already done 2 of them.
Sorry. Sad, so sad.
Save your answers.
Yeah. All right. Skip those. Why don't you do the reading instead right now, or work on something else for a second, and I'll fix those in a second. Yes. Calculator issue. Okay.
So like, I had all of that typed in, like, I don't know. I had like all of that typed into, and that's what my graph looks like.
Okay.
That's not right. They all look the same.
No, that's okay.
That's
If they all look, if they all look the same,
So I just go
then
with the first one?
you go with the first one then. Yeah. So the first one was really good, wasn't it? Was the first one. More importantly, what was the R squared on the first one? We go stat calc 4. So we get an R squared of 94.8%.
Because that didn't seem very high.
Well, yeah, it's not, but maybe the data's just not very, maybe it's kind of all over the place a little bit. So 94.8, let's try the other one. Let's go stat calc 5. Yeah, that's not much better at all. So 95, and let's just see if we keep going up. I think you're right, I think it's gonna be linear. Because the linear seem to do the job as well as anything. Yeah, for sure.
Okay.
Yeah, it's linear, yeah.
It was just different than everyone, so I was
Yeah,
confused.
but remember, I'm gonna have to, this is, which one is this? Is this the last one? Yeah, I wouldn't work too much more on it, I'm probably gonna have to delete your attempt.
Yeah, we could just, skip that assignment and give her.
No. This is, I gotta tell you though, this is, you may not, I mean, maybe you do, you can kind of get a sense that this is pretty amazing that you can do this, but like if you went back 15 years ago, this would have been so far out of the realm of possibility that you could just crank this out this easy. I mean, this is really amazing that this calculator is going to give you this kind of data this fast. This kind of analysis would have taken, because the math behind actually doing regressional analysis is, there's some big statistical formulas you can use, but it's pretty hard to do. I mean, it takes a while. It's pretty time intensive. And so that your calculator does this is just phenomenal.
Can we watch you fix the
I
code?
keep putting this in.
If you really want to. Okay.
Yeah.
This in, I keep-
I tried to do that's cool. I tried for like 2 weeks.
Let's see.
This is.
Those I would think would work, so I'm kind of wondering why this
Like
is.
I learned how to make a little guy wave on something like website.
Oh, I have a problem.
Pop up and say hi.
Yeah,
How
I
many
did that
sig figs
like
can
one
you
website
keep,
where you
first of all?
drag the code, so you're not actually writing it.
One, right? So let's just see if that fixes it. So that would be -4, actually, wouldn't it?
I
See what I'm saying?
like it. It's interesting.
Yeah, that's it all it was. Okay. It might have told you, did you look at the feed? No, maybe it won't. Yeah. Yeah, that's it, that's all it is. Remember, when you're taking a product, you gotta use sig figs. When you're doing sum or difference, then you use precision. Okay? All right.
Sam, just Alright, so I'm kind of confused on this.
Okay, I wonder if that has to be, that possibly has to be,
That's my profile picture.
The actual multiplication symbol.
I wonder, let's just see.
I just said something about that.
Oh, and then, okay, let's do something else. Cause it might want that in parentheses. So let's try actually going like this. Being as we're inside the editor, let's do that. What was it, a -8?
Yeah.
Yeah, when you're in the editor, no, doesn't like something.
Could you
Let's try
double
this
check
again.
my math real
Yeah,
quick? Just to
yeah,
make sure.
I betcha. So we're going, what color is that? Is that like gold?
Yeah,
That's kinda cool.
I picked it out because I figured it'd be really easy to see.
Yeah, exactly, yeah, that's a good idea. So 9.8, and then we just go second, EE is how we get scientific notation. -5.
I really
Times
like
-9.9.
Oops. Oh, that was my other question. How are we supposed to have a -9.9 for scientific notation when all of our numbers are supposed to be more between 1 and less than 10?
Okay, so, good question. It's the absolute value of the number.
Oh,
Yeah, you can have negative scientific numbers. So we get -9.7 times 10 to the -6.
alright.
Okay, so -9.7 times 10 to the -6 gives us.
Like, I can't update my iOS.
You can give me
Five.
five S, you can.
Oh, you have a five.
Five.
You can on a 5S, that's the, like the 5C and 5. It's kind of, it's a lot of stuff. They change up like messages.
Yeah.
It, is it like similar to the jump to iOS 7?
I don't remember the jump.
No, it's not that big.
No,
That was bigger.
huge.
I don't know what that's doing.
It's still like,
Yeah, we're trying.
it's still same font.
That was a small jump for man.
Well, yeah,
But a large jump for man.
-5, right?
Because that seems like the right answer though, too, because
Yeah.
we're taking,
It does.
yeah. I don't know, that's weird. I tell you what, this is odd that wouldn't work, because this has been used so many times, but just flag that one. When you turn it in, we'll look and see what it said the answer was.
Alright.
Yeah, I think you did it right though. What was the deal with H?
Yeah, I got the same answer, writing and all that.
Yeah, I think you did it right.
For number 8,
Yeah.
I ended up getting it right. I can't remember what issue I was having with it was.
I see one of it, because it should be 2 sig figs, right?
Yeah, but it said I got it right though.
Yeah, I wonder why it did that. So that might occasionally happen. Yeah, see, what's the deal?
Oh yeah, I remember what happened. It was I put in the 2 significant figures, and then I got it wrong, and then I did 1.74, and then I got it right.
See, that's.
Yeah, I think this was the one that I showed you about.
Oh, this is the one I made where it's 0. Yes, the one I made where it's 0.
Yeah.
Yeah. Yeah. So that one was wrong. I agree. But I want to see if that same thing's going on with this one now.
Now it says it's incorrect.
What is going on?
Yeah, like, that's what.
I'm getting that one.
This is weird. This wasn't doing this before. Let me just check. I was gonna see what this is. That seems right. 3 times 6. That seems right.
chair.
Yeah, that totally seems right. 3
Does the emoji replace my workflow? Probably did. No, I hate it.
Okay.
Multiplied those. So then I just wrote negative 6. And I moved it. And then that would be.
Oh, yeah, sure. Well, like, some issues sometimes, like, if you take it, it'll like, work with that. But, yeah, I mean, it gives you.
We were having these kind of problems last
Yeah, I
year.
thought I would.
Because I can't remember students coming up with issues like this all the time. And I was taught GA, so.
No, I don't remember this ever happening.
Why don't they make them?
Let me look at that one too. I'm not sure what's going on.
Do you want me to just submit it so you can look at it?
Would you mind? Yeah, let's just do that. Let's just go and see what they say the answer should be, so I can see.
Okay, my screen. Wait, did they make my
Oh, the code screwed up. Okay. See, that helps.
Yeah, that one I just got wrong. So,
Well, no, actually, you're fine. It should be, well, maybe you got wrong, but. God, that's. Huh, I'll have to go check. Something's really goofy there.
so for the division ones like that, I just have to make sure I have negative to the negative 10 power and to the negative 10 power on top, right?
To the -2 on the top and -10 on the bottom.
Oh,
Yeah.
and then I just divide them.
Yeah, just about, yeah.
All right.
Yeah, weird. I'll fix those. I don't know why it's doing that stuff. That's bizarre.
So do you want me to submit my